So in sections 2.2 and 2.3, we talked a lot about limits. So we said what was the limit, and that was talking about the y values. Then we talked about how to find the limit graphically and algebraically. So section 2.4 is about limits and continuity. Limits and continuity. So in high school, you probably learned a definition about a function being continuous, and that definition probably was you could draw it without picking up your pencil. So that's kind of the idea behind continuous. So for example, this function would be continuous because I can draw it without lifting out my pencil, whereas something like this, definitely not continuous because I had to pick up my pencil. We want to define that a little bit more rigorously, so that's what we're going to do with continuity. So the formal definition of continuity is, like I said, very formal, but this is the idea. Can I draw it without picking up my pencil, or do I have to pick up my pencil when I draw it? So when we say continuous, we're talking about at a point. So typically, we say continuous at a point. So we might say something like, is a function continuous at 2? So over here, maybe here's 2 on our function. Here's 2 right there. Is this function continuous at 2? Yes. I don't have to pick up my pencil when I draw nearby 2. Is it continuous over here? Yes, it's continuous at 2. What about at -1? So here are the points corresponding to it. Here, continuous at -1 because I don't pick up my pencil. Over here it's not. You can see that's where this jump is happening. So we want to put that in words of limits. So there are 3 things that have to be true about a function being continuous. We say a function is continuous at, let's say, x equals c, if the limit as x approaches c of f of x is f of c. Now I know this is just kind of one equality, but this actually means 3 different things. So really this is 3 things that are true. Number 1, I have to have that f of c is defined. Right, so I can't have that, that I can't even plug in c to my function. I have to have the f of c is defined. Second thing is I need the right and left hand limits to be equal. So I need the limit as x approaches c from the right to be the same as the limit as x approaches c from the left. So that's the second thing that I need. I need the function to be defined at this point. I need the left-hand and right-handed limits to be the same. And number 3, I need whatever the limit was that's equal in part 2 to be equal to the function value. So we need the limit as x approaches c of f of x to be that function value from a. So those are your 3 things. Number 1, f of c needs to have a value. I need to be able to plug in c to my function. Number 2, the left and right-handed limits need to be the same. And number 3, that limit has to be the function value. So that's the formal definition of a function being continuous at a point. If it's continuous over an interval, we would say it's continuous over an interval. If it's continuous over all real numbers, we say it's continuous over all real numbers. So you can always use the term that is continuous at more than one point, but typically we're talking about at a point.